we're not going to apply the information we have on factoring to solving equations that are quadratic or even slightly higher degree polynomials and different problem solving techniques. When we're given a polynomial equation, meaning we have two polynomials that are set equal to each other, our first goal is to often get it into standard form. And standard form basically is where we have it set equal to 0, and we write it in order of descending degrees so that we have a quadratic in the given form. This is really useful for the zero factor property, which states that if we have any number of factors being multiplied together and the product is 0, then at least one of the numbers has to be 0. So if two things multiplied together equal 0, then either A or B has to equal 0 in order for the equation to be true. This does not work if it's set equal to any other number. So when we take our quadratic or any polynomial for that fact and we get it factored, then what we can do is apply this property and state that, well, if our equation equals 0 while it's factored, then one of these variables or one of these factors has to also equal 0. And so we set both the factors equal to 0 and then we solve. And so once we have them set equal to 0, we can apply our addition property in order to get our solutions. And so in this case, we end up with two values of x, two possible solutions that cause our equation to equal 0 to make the equation true. If we have more than two factors, then we set each of those, again, equal to 0. Well, x equals 0 is already solved, and so we can go ahead and just apply our addition property for the other two factors, and we get three solutions of 0, -8, and +5. So our general process is going to be this. If the polynomial is not already factored and set equal to 0, like what we have here, which is rarely going to be the case, but sometimes it is, we want to write the equation in standard form so that one side equals 0. Then we'll go ahead and factor the polynomial ourselves. Then every factor that contains a variable is going to be set equal to 0, and then we solve the resulting equations. It's always a good idea to check your solutions in the original equation as well. Now, as we know in the past, not all polynomials can be factored, therefore not all polynomials can be solved by factoring. And the other methods for solving will be addressed in later units. So let's go ahead and solve by factoring. Since it's already in standard form, then we can go ahead and just factor, and we're looking for a product of a times c, which is -10, and a sum of 9. Well, the two numbers that are going to give us that are 10x and -x. We can go ahead and factor by grouping. So we're left with 2x minus 1 and x plus 5. Set both factors equal to 0, now that it's factored. And then we use our addition property and our multiplication properties of equality in order to solve. So we have our two solutions, 1/2 and -5. We're not in standard form, so we need to get it in standard form. First thing we'll do is distributive property. Let's clear out any parentheses. And then we'll subtract the 4 to give us standard form, set equal to 0. We'll go ahead and factor. We want a product of -8, sum of -7. So that's going to be -8x plus x. We can factor by grouping, leaving us with 2x plus 1 and x minus 4. We can set both factors equal to 0, and then we solve. So we get solutions of -1/2 and 4. Again, we'll apply our distributive property. Combine like terms. we will apply our addition property to group everything to the same side of the equation. And then we'll go ahead and factor. Here we have a perfect square trinomial, which factors to give us 3x plus 2 squared, which again is just 3x plus 2 as a factor twice. And if we set them equal to 0, we're going to get the same result. So we only really need to solve one of them. So when we have a perfect square trinomial, unlike our other quadratics, we're only going to have one solution because we have the same factor twice. Here, let's go ahead and start by getting rid of our fraction. Because we have an equation, we can multiply everything by 3, giving us 6x squared equals 17x plus 3. And then we can go ahead and write it in standard form. This makes it much easier for us to factor. Here we want a product of negative 18, a sum of negative 17. So we'll have negative 18x plus x. We factor through grouping. We set our factors equal to 0. And we solve. We write our equation in standard form. Now we have a GCF of x, so we'll factor that out. And then we see that we have a perfect square trinomial left over. I'm sorry, not perfect square trinomial, a difference of squares, which can be factored even further. X plus 2 and x minus 2. And then we have our GCF as the original. So we set all of these factors equal to 0. And then we can solve, and we get 3 solutions this time. 0, negative 2, and 2. Last but not least, we're going to go ahead and group standard form. And then since we have 4 terms, we'll factor by grouping. X squared minus 1 and x plus 5. X squared minus 1 is a difference of squares, so it can be factored further. Now that it is completely factored, we can set them equal to 0. And we solve. And we get 3 solutions. Negative 1, 1, and negative 5.